But you can't scramble these because you have to know going into it if it's arithmetic or geometric. So that didn't work. So anyways, half this lesson should take, like I said, almost no time. Really, really easy. Half of it is arithmetic. We're just going to fill in missing terms. And then a little more than half of it is geometric. Those are a little harder, but with the use of technology, calculators, we're going to have no troubles at all. So anyways, sequence like this is arithmetic. So by the way, I should tell you that these first two examples are arithmetic. You really need to know that. Otherwise, you wouldn't know which approach to take. And for the record, this could be a geometric sequence. If we didn't know, that's why someone has to tell us, there could be some really weird multiplier that goes from 5 to this, and then this to this, and then after a ton of iterations of that multiplication process, you're like, poof, oh my God, I got 26. But this is arithmetic. So anyone have a good strategy? It's think outside the box. Don't think about it as too like big of a deal. How could we fill in the blanks? What do we wish we knew? The number after 5. Like if I just knew, if someone would tell me that it was like a 9, then I could say, okay, now I know since it's arithmetic that the sequence is going to go, don't write this down, 5, 9, 13, 17, 21, 25. Do you get what I'm doing? So like if the second one was a 9, then the D would obviously have to be 4 because we're going up. This is what you practiced on Delta last week, right? But clearly that doesn't work, right? And so someone think creatively, how could I figure out what D actually is?
6 divided by 5 times 6. 6 minus 5.
Yeah, that was a really good team effort. I like the 26 minus 5, first of all, not the divided by. That's going to come in handy for the geometrics. But for the arithmetics, I really just want to know straight up, first off, this. How far is 26 away from 5? So what is 26 minus 5? 21. So we know that there's a distance of 21 between the numbers, and the question becomes, what am I going to divide by? And the logical thing to say is to divide by 6, right? But that's wrong. And what you have to think about is not how many blanks are there, but how many times would I have to jump to get from the first number, jump on all these lily pads and actually get to the 26. So count them out. You don't have to count out loud because it's like childish. I get it. But there's the first jump. There's 1, 2, 3, 4, 5, and 6 doesn't get me there, but the 7th jump does. So simple common sense really says that I've got to make up a span of 21 units, and I've got 7 jumps to do it, and 21 divided by 7 is 3. So we say in this case that the common difference is 3. I'm not going to have you writing formulas like I did last week. I know that if I asked you to, you could at this point because you can clearly see that A sub 1 is right here. You can clearly see that D is here, and you could write that formula just like you did on Wednesday and Thursday. I just want the missing terms. So if D is 3, what comes after the 5? After that? Good. And it should work out. If you just keep adding 3 and then 17 and then 20 and then 23, and you're like, hey, it worked, presto, just like a charm. If the difference is 3, then I fill in the sequence, no problem. All right. On a related note, we're also going to do one that goes downhill. So we're going to have -2, blank, 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 -57. So what we know for sure is that in a case like this, the D value's got to be negative because it gets smaller, right? So there's no doubt about that. So to find D, we simply have to perform that same set of 2 operations. And what were they again in order? Subtract and divide. That's it. So I need to figure out, first off, how big is the drop to go from -2 to -57? What's that drop? That's a drop of 55. You'd have to go down by 55 to get from -2 to -57, right? Now the question is, how many jumps does it take to get there? Oh, that's 5. And we learned from last time that it's just the number of blanks plus 1, right? Because if you make 4 jumps, you're not there yet. You only get to the 4th lily pad. You've got to make that one more jump to get to the actual number. So if you take the distance between the two and you divide it by the number of jumps, which is 5, what do you get? Negative 11, which tells us now that we can fill in the sequence by just subtracting 11 over and over again. So what's after the negative 2? Negative 13. What's after that? After that? Negative 35 after that? Negative 46. And then, of course, it fits. All right, if you get to the end and it doesn't, if the pattern doesn't work, then obviously something's gone awry. And it could be in finding your D value. It could be in just the you added wrong or something. Who knows? You got to figure that out. All right, any questions on that? All right, the second half of this, it's actually not half. I don't know it's like 60% because we have 2 and then 3. We have 3 examples of this, and these are all going to be geometric. And again, if I didn't tell you that, that's not good. That would be some bad teaching practice right there. So like if I just said, ooh, the big blinks, I made those blinks big. Oh. If I just said fill in the blanks and I didn't tell you what kind of sequence it was, you could approach this as an arithmetic and you would figure out that the drop is negative 484 and then you would divide by 5 and you could figure it out, but it's not. I'm telling you straight up, it's a geometric sequence. These are significantly harder to do. Like you get to a point with those last ones where you could do them in your head. Honestly, it's not bad. These ones are a little bit more rough. And, I think you guys kind of teamworked up to figure out how to do the arithmetics. You want to think about how to do the geometrics? It does start with dividing these two. That's something that I do need to know, is I need to know, because this is just a snapshot of a sequence, right? What I don't have here, it's not very professional, is there should be a dot, dot, dot here, and there should be a dot, dot, dot here. So really, we're just looking at one snippet of an infinitely long sequence. We know right now, well, we don't know what D is, but we know if we take this one and we divide it by this one, we take negative 486 and we divide it by negative 2. What do we get? We get 243. Now, it's very crazy to think about, man, I'd be really impressed if you can make sense of this. But anyone want to take a shot at what we do with the 243? Yep.
So can we divide by 2?
We don't. Does not involve division. Say again? Yes, it does involve roots. Basically, a geometric sequence is just a buffed up, like it's an arithmetic sequence, but it's like, I'm going to take this to the next level. Like I'm more, sorry for the pun, powerful. And so when we have a geometric sequence like this, division and subtraction don't cut the mustard. Like, think of it like next level, like arithmetic went subtraction, division over. This one goes division, root over. And so what you're going to do is you're going to grab your calculators, unless you've memorized all of the roots, which, by the way, impressive. And you're going to take the 243 and you're going to calculate the root. However, I have written a square root. That's not what we want. Again, it comes down to how many iterations of the jumping process transpired. To go from the negative 2 to the negative 486, how many jumps were there? There were 5, but they were geometric jumps, which is why subtraction isn't going to help us here. So there are 5 jumps. So what you're going to do is you're going to type into your calculator the 5th root of 243. If you don't know how to type that in, let me grab a copycat of one of yours so I can tell you where the button is. So you guys are going to want to go into the math menu. And you're going to want to hit that 5th option down. And it gives you a little root sign with 2 cursors. There's a cursor flashing in the index, and there's a cursor not flashing yet inside the radicand, inside the radical. And so what you want to know is what's the 5th root of 243. There have been effectively 5 iterations of a division process, which becomes a root. And the answer to this is 3. What do we take from that? that it's multiplicative by 3, right? So if we say fill in the sequence, now you can just take every term and multiply it subsequently by 3. You get -6, -18, -54, -162, and there you go. So when doing arithmetic, it's subtract and then divide. When doing geometric, it's divide and then root. Let's practice. That one's a little bit rougher. Let's practice it just a couple more times, and then we're done. Oops. So this one, we're going to do 1 blank 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 1,296. If you're a math person, you might already, your spidey math sense might already be telling you, I think I know what this is already, but let's write it out. Step 1, divide. The end of what you can see by the front of what you are looking at. So 1,296 divided by 1 is, of course, 1,296. And then what root are we going to do? The fourth, because there's 4 jumps to get from point A to point B. So you're just going to type into your calculator the 4th root of 1,296. And what did you get? 6. And so that tells us that we cracked the code. This sequence can be filled in with times 6s. So 6, 36, 216. One more just for good measure, and then I am stepping aside here. 2, blank number 1, blank number 2, blank number 3, blank number 4, blank number 5, and then 235,298. We're not scared, right? And I'm staying away, at least for today, from all the fractional sorts of ones where you get answers like, multiplying by 5 hats or something like that. These are all nice. Step 1, divide. So take the end number divided by the first number, and you get, what is that, 117,649. And we're going to take what root? The 6th root. And thank goodness for calculators. Brady was a step ahead of all of us, and you said that it comes out to be 7. So then you just now know that 7 is the magic. What R, remember we learned Thursday or Wednesday that R is what we call the common ratio in a geometric sequence. So times 7 is 14, times 7 is 98. And then that's where I started using my calculator. So times 7 is 686. Times 7 is 4802, times 7 is 33,614. And I would advise against using commas, because a guy like me is usually going to get up and cloud up and rain on you if you don't put a comma in a big long number like that. But obviously we don't want commas in them, because then they start to look like they're commas in the sequence, which we don't want. So long numbers, we just need to write as long numbers and suck it up. Do you have any questions about how to fill in missing terms in arithmetic or geometric sequences? That's it.
No math.